In this video, we are going to demonstrate the synchronization of two Titan controllers with one Titan controller as a master and the other Titan controller as a slave. For this demo, we will use two TITAN-IMX units. Master will be the triple-stack NEMA 23 TITAN-IMX with a 4000 count encoder with differential encoder signals outputting as shown here. The slave Titan will be the triple-stack NEMA 23 TITAN-IMX unit with a 16,000 count encoder. The encoder output signals A, B, and C from the master Titan are connected to the pulse control inputs of the slave Titan. The first thing that we need to do is to set up the slave Titan. Let's check the communication with the slave Titan unit. Next, let's go to the configuration screen. Let's enable the second incremental encoder input. Let's set the mode to pulse mode. Let's now set up the electronic gearing. Since the master has 4000 counts per rev encoder, and the slave has 16,000 counts per rev encoder, we will set up the electronic gearing so that they match the motion 1-to-1. Let's set up the numerator as 16 and the denominator as 4. This means one revolution of the master will result in one revolution of the slave even though two have different encoder resolutions. For the slave motion direction, you can use the motor direction setting to change the direction with respect to the master. For this demo, we will keep it as is. Keep the other values as default and download the new values. Go to the test drive screen and enable the motor. The slave is now waiting for the encoder signals coming from the master to perform target moves. Let's communicate with the master Titan now. Disable the motor and manually turn the motor. We see that when we rotate the master, the slave unit moves the same amount using the electronic gearing. Let's enable the master Titan and do some simple motions. Run a cycle motion using an A-script program. I hope that this tutorial video was helpful in setting up a master-slave motion system using the Titan servo controllers.